Okay, so today we'll study, some more features of access control, and these are little complicated concepts, right? So it will take a while for you to understand it, but once you do hands-on exercises, then you should be able to understand it very easily. Okay, although not many books cover this feature that we'll be studying today, it's mostly available on papers. Of course, a book by Professor Du has enough contents on it. However, is generally slightly difficult concepts, right? But I'm trying to explain it whatever best I can do. So please feel free to ask questions if you get stuck. Okay, all right. Okay, so basically these three references I've used Professor Wen Liang Du's book. As I said, he works in teaches in Syracuse University, and this book is available to all of you. Professor Van Ottschot's book, and then there's a paper written by Matt Bishop. Professor Matt Bishop also has a book on security, but this is a paper which says that how to write set UID programs. So I have also read a bit of it, right? Not full, but some aspects of this feature. All right. So these are the contents. So we'll just get into background what we have covered in the last class. Just a minute. Sorry, I'm back. There was some noise happening outside. All right. So this is what we know, but please start using Linux. I will send you an exercise very soon because I was waiting for this lecture to be over, and then we'll send you exercise which will use this feature. Okay, so in any OS, and primarily Linux and Unix, very important concept is that of user ID. And user ID defines what privileges user has. Now, when we say user, then whenever a user creates process, okay, in the TCB of that process, you have user ID, right? PCB or TCB or process control block. It means that with every process there is a user ID, right? So if you want to know what is your user ID, if you're running this on Unix, Linux shell or terminal, then you will get this, right? Okay, so for example, user ID for me on Linux VM is UID equal to 1000, and name is Ravim. Okay, similarly, group ID is 1000. And then it tells me what are the different groups that I am associated with. This account is associated. All right. So user ID is very important. Note that it provides the access control. Okay. All right. Okay. All right. So with each process, whenever process created, then user ID associated. And a process creates sub-process, then again user ID is associated with that. Okay. So you can see if you have process running, for example, in my VM, the process running is 1800. Okay, one of the process 1800 process. Then I can say, and you can find out what process running in your laptop, and you say PS minus U minus PID, which is process ID. Then it gives a user ID associated with that process, particular process. So you, for example, if I run this, then I will there's one process is running which is 1800, so it will give me who's a user ID for that. All right. So try this exercise. Okay. So you should, with any process, you can find out who is the user for that, user ID for that. Okay. This we have studied in the last class. Okay. Now you would have come across this term, access control list. Okay. We'll study this in later lectures. Okay. But in general, access control list, for example, in a router, there is access control list. Okay, with any file we can have access control list, or with any object we can have access control list. So if there is it's like this, the object, for example, is there's a dinner banquet happening somewhere, and there's a sentry here. Okay, and then sentry is given a list of people who are allowed to come inside. Okay, so this thing, this list, that says that a user 1, for example, have access to object 1, which could be, for example, non-veg dinner. Okay, user 2 has access to, say, veg dinner, and user 3, like me, will have vegan dinner. Okay, and then some categories, right? So now if I go to a hall, then sentry will look at me and look at what I am eligible for, and then send me around. So this is called access control. Similarly, with each object, which is a file, for example, a file, a list of users who are allowed to access that is called access control list, right? Okay. And then it will say what kind of accesses is permitted to it. For example, there is a file. For that, we have number of users who can use it, or number of processes that can use it, and what it can use it for, then that's defined through read, write, execute. Okay, bits. So you can find out what is a access control list for a file. For example, on my VM or Linux terminal, there is media file, and then when I use this command get facl, then I will come to know who are the users allowed to use it. Of course, in my machine, I am the only user, so it will say that user and so on, right? So owner is root and group is also root. Obviously, that's allowed. All right. So we'll study this in later lectures. Okay. All right. And we have also studied that in Linux, apart from ACL, there is very simple access control mechanism that's called UGO model, right? Wherein with each file, there we have 3 categories, which is user, group, and others. This is very simple access control model, right? And then we have 3 bits: read, write, execute, read, write, execute, and so on. Okay, the user is the owner. All right. So we have file-based access control. So wherein, what happens, and OS course you have studied that when we do IO, when we represent a printer or a card reader or keyboard, all are considered as a file. And when we do read, write, and other operations on file which are permitted, all that are performed on corresponding device. Okay, so most of the things in OS, are represented as a file, which are the objects. Okay, all right. Now with these objects, we have access control using these ones. Okay. So with each file associate owner. So note that with each file or each object, there is a concept of owner. Okay. And okay. Now there might be files which we are not able to read or write. Okay, there are a lot of files in system, right? And then for that, for example, file used by OS to do certain tasks, the owner is the root. Now, root is their super user. Now, you means that you as a user can be given super user privileges. Okay, when you are giving those privileges, then your UID becomes 0. You have privileges of UID equivalent to 0. Okay, all right. However, the process which has username with UID 0 is the root. So you can be given temporarily root privileges, which is fine. Okay, so we'll come to that concept little later. Okay, remember that this model is very simple model, UGO model, that with any object you create 3 categories of users. Okay, first is the owner. Okay, second is a group, and third is others. We studied this in last class, right? Owner is usually 1. Okay, owner of the process. You created a file, you are the owner. Then you can define that what are the members in, for example, your class only, who can use this. Then you define a group of say 50 students who can use this, right? So group can be defined. So now group, you may want to write into the file, but you may not want any user to write into the file. Then you say that group permission there is only for reading. Okay, and so on. And all other students, then you don't want to give any permission. So this very simple model that is heavily used nowadays, most of the ways, because it's, it does not, you don't have to traverse a list like in ACL to find out whether a particular student has access rights or not. Here you simply look at user ID. Okay, and then user ID, then it will check it's not owner, then it's not in the group, because group number of members are well defined. Then a person will have others, what others can do, those permissions are there. So access control becomes extremely simple. So we have user category, group category, and others category. Group category, you can define what are the groups, like class or your class, say, or your batch, or all group can also be all in say IIT Goa and so on. Okay, so UGO model allows fixed size metadata entries. Okay, these are the metadata entries, right? And it's very simple then. Unlike ACL, where you have large list, I mean a number of, with an object, for example a file, this list, which is a linked list, can be as big as 500 and so on. Then you have to traverse the list, and then you have to think of better data structures and so on. So it becomes anyway complex, but this model is very simple. Okay, and we have studied that we need 9 bits. Okay, these are 9 bits here. Okay, any question up to this point? Okay, just recall, what is this D bit? Anyone? Directory. Is a directory, right? So bit is 1, it means that directory, and other, if 0, then file. Okay, all right, simple so far, right? So now if a user process is requested for a file, then system checks whether process is, that particular process, that user process has permission or not. If permission is there, if user ID matches with owner's ID, fine, all permissions are there. If it's a group ID, then limited permissions, whatever have been defined. Otherwise, others, it will come into others category. So simple. Now the question is that, do we need more than this? Okay, so something called privileged programs. So we'll now, in this class, we'll study about privileged programs. Okay, now look, let's come back to the password thing, right? So there is a file called password file. Okay, if you do simple cat, then you can print the password. It's simple. Okay, and passwords, so early days passwords were visible to all. Okay, early days means that about 30-40 years back. Okay, because there is not so much concern about security. Okay, and then we know that encrypted, now passwords were earlier when in plain text, so it was visible to all. Then it was even okay. All right. Okay. So passwords are visible to all. Now the question is that why not keep the encrypted passwords in the password file? One can keep that, right? Now somebody reads that password file will get, corresponding to a user encrypted password. Now OS thinks that, I mean, people, OS designers think that is not a neat way, right? Because I will come to know on the system, for example, this server, I will come to know what are the encrypted passwords. So it's kind of already hacking or encrypted or hash password. And our data breaches are done essentially to get this. And then we have studied there are tools to break it, right? So now we don't want to have that possibility. So we keep this passwords in a shadow file. Okay, now shadow file, if you say that cat shadow file, okay, right, then you will not be able to read that. Only root can read that. Okay, so you can of course see what is the permissions of shadow file. You'll see that only root is writable only by root, and of course readable by a group. So maybe owner is the group, only person in the group is the owner. Okay, or maybe some processes which are defined, but writable only by the owner. Okay, all right, so that's the purpose of keeping it separately. And this even other users cannot even read that. So if you run cat/etc/shadow, then you will not get anything out of it. All right, so here is one. So when I run ls-l/etc/shadow, I know all this, right, that we have shown in last slide. And now I want to change the password. Whose password? I'm changing my password. To run this password passwd, so it asks for changing password for the user, okay, which is me, because I am running this command password, because I am the user. Okay, then you'll ask me current password, new password, retype password, and successfully change. Now the question that is that who is doing this? Who is modifying my password? OS? It is not OS. It is assisted by OS. Of course, everything is assisted by OS, right? Even execution of this password that we are doing is also assisted by OS. All right. So there is something called super user. Okay, so we'll come to the solution later, but meanwhile, let's look at who is super user and what are privileges, right? Root is of course super user. Okay. So you log into root super user, which is a root account, and you can do anything you want. But this is not something that's recommended, right? That any user is allowed to get into super user account, because then can do anything. It's simplest possible hacking. Okay. Now, in limited way, super user actions can be done by using a sudo command. Okay. Sudo command, for example, okay, normally when you do more etc sudo etc/shadow, here I am doing the permission is denied. Okay, you cannot open that shadow file, you cannot even print, right? Okay, but when I use sudo more this one, then I can see that, because sudo now runs, when you say sudo, then my process which is asking for it, user process which is asking for this data, is running with process ID 0. But how is it happening? Okay, because there is something called sudo file, and in that the name, my name is there. Okay, so the question is that, okay, is sudo a security threat? See, look at this example. We say that I can, run sudo and find out user ID for some other user. So with sudo you can do that. Okay, all right, as a user option. Okay, if so sudo file should have the name of users, right? Okay, all right. So, and then look at some other commands like su bob, which is nothing but substitute user bob. It will ask for that user's password, not your password. Suppose you want to run the process as your friend. Okay, now your friend privileges could be different from your privileges. Okay, and you know it, then you say su change user or substitute user to your friend's name, and then you are allowed that, provided you have your friend's password, because system will ask you for password. Similarly, you can change it to root by this as su dash, but you need super user's password, root's password. Okay, so read more about this sudo command, try running that, you will get a feel for it, right? So we very often in your Linux machine, you are the only person, you are also root, your root belongs to you, right? So root password, and when you are in however you are running everything from your account, not from root account, even all the machine is yours, right? Then if you run a process and then it doesn't allow you to do things like, for example, reading shadow file, then use super user powers, right? So you do sudo, and then you can go ahead. All right, okay, now let's move on. Any question up to this point? No? All right, let's look at now, coming back, that who changes a password. So passwords are there in shadow file. Okay, and then and you see who is read write, all right, so when you do this, you will come to know only root has write permission. Okay, normal user which is here cannot even do read and write of the file, but normal user should be able to modify the password. So what is the solution of this? There are many solutions have been tried. First is that give fine-grained access control to user. For example, I am trying to change my password in shadow file, then allow me to change only my password. Okay, at the field level in the password, at the entry level in the password. Okay, now note that OSs allow access to any file at the file level. See, these are minimum access that's provided is at the file level. See, you can read, write, or execute a file. But you cannot, and it has multiple elements. You can't say that this user, say user 1, has access only to this element. That's not allowed. Okay, because if you allow this, then OS complexity will go up, and this is not right. Okay, so this method has been tried and then was rejected because OS become more complex. Then the question is that what else can be done? Second method or second approach, or actual approach which is being used, is that there is a background process running, okay, which we call privileged process, and then is kind of OS privileged process, and then it's specially meant to do these password changes. Okay, and then you make a request to that process, and the process will be able to change the contents of the password, but you are not directly allowed to do this, right? So this may be a password file or any other resource. Okay, so corresponding to a resource, there will be a privileged process running to do a special task. Okay, but this was used in many OSs earlier, but I did. So it means that for every privilege operation you have to run a process. So this may be very expensive. Okay, so this method is also not used. So now the method that is used is called two-tier approach. So this is a program, a user program, ordinary program, say for example with others privileges. Now it can do ordinary read and write. Of course it can do on objects for which its owner, it can do whatever it wants, right? So this is called normal access control, simple and generic access control. For allow user to do whatever is eligible for. Now if you want to do something special like changing shadow file or something, or changing your password, then you have to come through your request, like password change request will come through a program, okay, which is specially designed for that, is called privileged program. Okay, now this privileged program can do password change on your behalf. All right, so we have privileged programs and application. Now these privileged programs are application specific, meant to do only specific job. Okay, and cannot do anything. So now user, in some sense, if you see, user has kind of control, okay, but it is through somebody, and through somebody can do only limited amount of tasks. Okay, all right, so Unix implements an extension called privileged program, say for example password program. Yeah, this program will be password program, which can modify shadow files for others, but user directly cannot modify shadow files. Now the simple question I'm asking is where this privileged program will be. It has to be absolutely trustworthy. Okay, and it's generally in TCP. Now, no, don't get confused with thread control block. Is trusted computing base or in the OS. All right. So now let's look at very specific UID, set UID mechanism. Okay. Okay. So your user ID is 1000. Like my user ID is 1000. Okay. And I want to access a file. So it will check, OS will check UGO bit, user group and other bit, and find out if I have permission. Okay, now if I am in the others category, whether permission is there or not, accordingly I will be allowed to read or write a file. All right. Okay, now note that for every process in Unix, although we have defined only one ID, Okay, user ID. Here user ID is, of course, user is one, but there's a process ID, right? Apart from that, each process is uh, a process ID, PID. Okay, and also has correspondingly user associated. So we have also have user ID. Okay, hope there is no confusion. Every process has a process ID, right? And every process associated with user or owner, so it has a user ID. Okay, which is nothing but owner ID. Okay, and when we a process wants to access a resource, then that owner ID is looked at it, or user ID, and then permission is granted. Now there's a confusion here, right? So now this user ID, which we say is single user ID, is actually not internally is implemented as 3 user IDs. First is called real user ID, which is nothing but user ID, normal user ID. Then effective user ID, and then saved user ID. The one which is used for access control of a file or resource is effective user ID. We'll look at this, right? So now you are trying to read a file, then not my original user ID. I am Ravim, for example. So I have so my and you know, if I am okay, so okay, so I have my user ID. Okay, and then for this file we have these 3, and we'll check where I fall into, and accordingly it will permit. So now here what it says that my user ID is not used, but effective user ID is used. Like I was telling 1000 something, that is not used, right? Then effective user. The question is that what is then effective user ID? For ordinary reading and writing, real user ID and effective user ID is the same. But there must be some mechanism to change my real user ID, and convert it or add something to it or change something to it to make it effective user ID. If, for example, my user ID is 1000, for certain operations, my privileges can be higher. So my effective user ID is that of a root. Okay, so let's look at this concept. Okay, so there is something privileged. There is a privileged program called set user ID program, which is like any other Unix program, except that it's a special marking of single bit, which is set UID bit. We'll look at this little later, right? Now, process of this bit is to tell operating system that when program is executed, it should be treated differently than those without such a bit. Okay, so now remember some time back we have seen that every object or file or a program has these 3, right? 9 bits. Okay, corresponding to owner, group, and other 9 bits. And apart from that, there are 3 more bits. This one of the 3 bits here is called set user ID bit. Now, if this bit is set, then this program, the file, when executes becomes program, has different rights, and that we'll see what are those rights. Okay. A normal program is non-set UID program, like a normal program that we execute is non-user ID program. Okay, so effective user ID is same as real user ID. When user runs set user ID program, then effective user ID becomes that of a ID of the owner of that program. See, I am a user process. I am running a program. Say change password program. Okay, but I am not the owner of that. Okay, however, if in that program this one bit is set, then I am allowed to do something. Okay, because now the user of that, or the permissions of that becomes that of the owner. Okay, so you'll see it here. So again, to repeat, there are three user IDs. Real user ID is user ID of the process that's running the program. Effective user ID is used in access control or permission checks. This ID represents the privileges that the process has. And the saved user ID, let's not worry about it, because it is stored the previous user ID so that it can be restored back. All right. Similarly, we have three group IDs: real group ID, effective group ID, and saved group ID. So we'll not focus on this, but focus only on set UID. Now look at this diagram, which I try to make based on my understanding. So I'm running a process. My user ID is 1000. Okay, I am running a program. Okay, this is a process which is running a program. Okay, for example, it could be a very special text editor. Okay, and this editor, which is here, is non-set UID program. Okay, so in order to do anything, it will check who is using it. So it will check my ID, which is nothing but effective user ID, which is 1000. Okay, and it's trying to read this program based on these permissions. Is trying to read a file which has UGO bits as 111, 000, and 000. Okay, so I am not falling into this category. I am falling in this category. So I am not allowed. So now text editor with UID 1000 cannot read the file when set UID bit is equal to 0. Okay, now in order to make, now what can I do? Okay, now this special text editor is now set UID program. When we say set UID program, the file basically, program is nothing but a file. When it executes, it becomes process, right? So when you say program here is nothing but a process in some sense, right? So when this, and actually is a file like ELF file, that goes to memory and you load it up, and that ELF file has program. When you load it up, it becomes process, right? So this has, so that file has all these 12 bits, not this one. So 9 is regular one, and then we have 3 special bits. Now if you set this bit, first bit of that, which is set UID bit, then this become special program. Special, right? Special in what sense? Who is the owner of this text editor? Owner of the text editor is, for example, root with UID is equal to 0. Then the effective, now who's the user of this? The user of this is UID. Say, for example, I am. Okay. So when this bit is set, okay, in this one, this bit set UID bit is 1, and the owner of this program is root, then when this program is executed, then the effective user, which is actually initially UID, now effective user ID becomes 0, which is root. Now as a result of that, this program can do reading or writing on this file on my behalf. But I am still not directly doing that. I am not allowed to do that. But this program, for this program, the user ID becomes 0 or root. And then we look at permissions of the root. OS will look permissions and allow this file access. Any question? Is it a little confusing? Are you able to understand? If
Yes.
not, If not, then you please think about it, right? So it took me a couple of days, if I won't say hours, to understand it. Okay, all right. So how to turn a program into set UID program, that we have already discussed. They are normal 3 permission bits. In addition to that, sorry, 9 bits permission, there are 3 special bits, which are set UID, set GID, and T bits. Okay, we'll not worry about set UID, set GID. If you are interested, read it. Set UID bit, when file owner, because ultimately you are trying to read a file. Okay, if the file owner turns this bit for any binary executive file, say file 1. Okay, so so this is special program, and then you turn this special bit as 1, then this access rights of this becomes that of the owner of the file. Okay, so this allows, so yeah, what I've said just now is essentially this allows file 1 during execution, which is this special program, because ultimately we have to set this bit in the file, so when it executes also it has a permission. Okay, and then OS checks this and then allows, because this effective user ID becomes that of a owner of the file. Here in our case we have taken owner as root, then that permissions are checked when this program reads a special file, whatever file, right? Say password file or whatever. Okay, all right. So this is the way it is. So these are the 9 bits for a file or a program. Both are the same thing. Okay. File, when execution becomes program, which is of course executable file. Okay. So for even a program or process, I mean, let's interchangeably use this word program and process, because everything is same right now, or program in execution. Okay, so this bit, whatever there is file, that executable file, read, write, all these remain. This is the normal one. Okay, and apart from that we have 3 extra bits: set UID bit, then set GID bit, and T bits. This corresponds to this one, right? First, set UID bits corresponds to user of the file or owner of the file. Okay, second corresponds to group, and third corresponds to others. So if we basically, not to confuse you, there are 9 bits, regular one, and 3 bits. Okay, now the first bit is corresponding to the user of the file, the effective owner or owner of the file. Then if, at the time of execution, okay, it's only at the time of execution. So at the time of execution of that file, program or file, the owner ship changes, right? So effective user ID becomes something else. Okay, so initially it could be anybody who is running a program. I am running a some special program. Okay, but when this bit is set UID bit, then I will have effective user ID will be corresponding to that of the owner. Okay, of course you go through this is nothing but it tells whatever we have read earlier. It's nothing. All right, so this is what okay, so how do we set then? There is a program, ordinary program. Say we write some program, say for some doing special. How to change this to a set UID program? My chmod command, right? So if you set it of you, now this is a program 1. Okay, and its permissions are, for example, this is 755. On normal case it's 0755. when it's non-set UID program. If you want to make set ID program, this bit is 1, all others are 0, so it becomes then then if you say change mode of this program, then it becomes 4755 permissions. Right? So if you use ch modes 4755 program 1, it becomes special program. All right. So set UID program allows normal user to escalate their privileges. However, it is different from directly giving privileges to users, right? Because it is always user is this one is always through someone, and then it is doing some limited task. Okay, all right. Because set UID program, okay, when set UID, this becomes set UID program, then normal user can do whatever is included in the program. So because user does not have super power, but it can get the work done only through this set UID program, which is kind of special. This program, although ordinary, becomes special program. Okay, all right. Okay, so is it safe to turn all programs into set UID programs? No, this is a security threat. Okay, for example, shell program cannot be made into set UID program, because if it's made, then user can do anything. If if shell program, if you give root privileges using set UID program, then user can do anything. All right. So this is one such example. Another few minutes and then I'll stop. Okay, so this is a okay. If I want to change, okay, let's run this one. So I'm running /bin cat. Okay. So what I'm doing is, sorry, I'm copying ordinary cat program, the cat program that's there, into my cat in my directory, right? In my directory, I'm copying this to my cat. Okay, and when I do ls-ls, I can see that there is a my cat program, which is nothing but copy of the cat program. Well, cat program just displays, right? So now I have duplicated that. Now what happens now? Who is the owner here of my cat program? I am the owner. Okay. So now if I change, now what I'm doing, now I want to read, actually my intent is to read shadow file. So if I run shadow file through my cat, it will not allow. So I change my own owner of this to root. Okay. So now I'm changing the owner of my cat to root. Okay, all right. So that you can do with chown command, chown root to my cat. Fine, it's done. It will ask only for my password, which I gave. It will. Okay, now you do ls-l my cat, then we'll come to know that owner of this program, my cat program, is root. Okay, now if you run this, my cat, and then you run shadow files /bin shadow or /etc shadow, just yeah, /etc shadow. No, it will not allow. Why? Anybody tell me why it will not allow? So for example, when I'm running this, it will say permission denied. The owner of the program, my cat, is root. Why is it not allowing me? Because the user ID is me. Who's the user ID? User ID is here, Ravi, right? So my user ID is checked. All the owner is somebody. Okay, because I don't have right of roots. Now if I do, you change the rights of this, program mycat as ch by this command chmod 74755 and owner is root, right? Then me here has now rights of the owner, which is root. Okay. Now if I run now mycat /etc shadow, I can see the contents. Okay, any question? Please go through it again and read also from book. If you have confusion, is complex. Is little complex. Okay. All right. This we have already done. Now the another 2 minutes. Can we take over Bob's machine in 1 minute? You and Bob, you and your friends are working on a department machine in a lab. And Bob says, I'm going to toilet and come back within a minute. Now this machine is open, terminal is open. Now you can, okay, and your account is also open the same machine. So what can you do in 1 minute then? Of course, you can send an email on his behalf to all, whatever. But what more things you can do? Okay. Okay, so I want something special, right? So if I use my shell program, then I can work only within my account. If I want to run shell program on his behalf, then user ID of the shell process should be that of Bob. Okay, then how can I run from my machine and open a shell whose user ID is Bob? Then I can do anything, right? Okay. So if I'm able to run shell program on behalf of Bob, I have taken over Bob's machine. Okay, so what I will do? So I will go to Bob's machine because I have still 1 minute. So I will do copy /bin/shell into some temporary folder. Okay, note that this temporary folder is visible on a server, visible to all, usable by all. Okay, and the owner of now my shell program is the Bob. So he's because I'm doing it in Bob's machine. Okay, and in Bob's account I need to set ID bit of my sh program, right? Now, so now what I do is that because I do this because I want to run shell owned by Bob, so I have access to everything that Bob can do from shell. Okay, so I do chmod 4755/temp fly /my shell. Right. So now what happens is that this program has now owner. Now I am setting this, so owner is the Bob. Okay, and this program is available in temp file. Okay, now I go to my machine and run this /temp my shell, which is in temp file. Okay, then I have a shell which is whose effective user ID is Bob. So I can do everything, whatever I want to do on Bob's machine. Okay, all right. So there's a lot of things which can go wrong with privileged programs. I want you to read these slides. Okay, and in the next class we'll see that what all can go wrong with privileged programs, and this has been one of the known holes, and of course companies are doing to plug it up, but programmers can do a lot of mistakes and use with set UID while writing set UID program, and that criminals can exploit. Okay, so let's stop it here, and if you have any question, please let me know. Okay, all right, are you able to understand it? How many of you are able to understand this? Yashi, are you able to understand? No? All right, then let's stop.